Hi, everyone. Welcome back. So this is lecture 2. Today we'll start our analysis of the simple linear regression model in the first half of class. And then we'll see how can we derive the least square estimator and how we can estimate the model and interpret those results by using those estimators. And then in the second half of the class, we'll talk about something like probability of those estimators. Because this topic is kind of hard, so to make it easier for you, I just divide the lecture into 2 short parts. And by the end of the class today, you will understand why the estimation procedure that I will show you in class today have become so popular and so widely used. So let's begin with a question that seems very simple. So, how does the household income affect how much people spend on food? And in the real life, both the income and the spending vary from person to person, right? So, in the statistic, we say those things are random variables, and we want to using some data to learn about this relationship. So we'll build something we call it econometric model, and a model that can combine the economic theory with a real world randomness. So for example, the economic theory can tell us that the income will affect our expenditure. So we can easily to set in our model that the expenditure is our dependent variable and the income is the independent variable. So or maybe we can also call it external variable. Of course, theory is just the only part of the story, and in real life, other factors can also influence our how much our expenditure, and there are something that we don't always observe, right? So we can add one random item. So it can help us to capture everything else that might affect expenditure, but isn't directly included in the current model. So when we're doing that, we move from our economic theory to our econometric model, and something we can estimate with the data. And the most widely used economical model in both research and industry is the linear regression model. And we can see that not just for the business economics, but we can also see that things in like the medical industry and so on. Let's focus on the simple case now. This is a simple linear regression model. So we can find here is the equation y equal to beta 1 plus beta 2x and plus e, which is the error term. So in this model, there are 2 parts. The first part is the systematic part coming from the theory. That's the beta 1 plus beta 2x. And there is a random part and the error term e. So it represents unbound variation. So in our model, the y it represents the food expenditure, the x the income, and beta one we call it intercept, and so it's equal to the value of y1, the x equal to 0, and beta 2 we call it slope. So it will showing us how much the spending increasing for per actual dollar of income. So we can find that there are two main assumptions here. The first thing is that we assume here there is the only one external variable, that's the income, that can systematically affect the food spending. And then the second main assumption is that we just assume the relationship is linear. So here we just use the plus beta 1 plus beta 2x and plus error term. So we're assuming the relationship between the income and expenditure as linear. And but it's really true. Think about that, right? So not quite. In fact, this model, yeah, is obviously wrong, right? Because other variables can surely matters. So we can think about some other factors. For example, the number of people in the household, right? A family of 4 spend more than a single person. Or we can think of another factors like the location. Grocery in New York are more expensive in Dallas, right? And then how about the linearity assumption? So we can easily to imagine there are 2 households, and for the first household, they can earning $2,000 per week. So if they spend 10% on that on food, that's $200, right? So just use the $2,000 multiple the 10%, so it's equal to $200. Now imagine the second household, they earning $10,000 per week. And then if they spend 10% that on food, that should be 1,000 per week. But do you think they will really spend $10,000 per week just on food? Of course not, right? So people cannot eat that much. And so we can find that as income increase, the percentage spending on food declines. So actually, this is the classical case of a non-linear relationship. So yes, the simple linear regression model is not realistic because it ignores some other variables and it has some wrongly assumption about their linearity relationship. But it's still powerful because it can help us to building some intuition and it can give us a starting point for some advanced models. So in this course, we can first to learn how to estimate the simple model, and later we'll relax those assumptions and to make our models more realistic